Hey guys, welcome to question FM341 of the Further Maths Fortify study guide. This question reads, Gordon will travel from Sydney to Los Angeles on Tuesday the 6th of March. The flight will leave Sydney at 11:40 a.m. and will take 14 hours and 20 minutes to reach Los Angeles. At this time of year, Los Angeles is 19 hours behind Sydney time. Question A says, on what day and at what time will Gordon arrive in Los Angeles? Well, the way that I like to set up these questions is by first creating the departure time. So we're going to do this in Sydney time to begin with. So wherever we're departing from, we take that time. So this is going to be Sydney, 11:40 a.m. on Tuesday the 6th. And we'll leave the March out for the moment because this isn't going to change so much that we end up at a different month. So let's keep on rolling. The next thing I'm going to do is take the landing time or the arrival time, but still in the time zone that we departed from. So we're still going to keep this in Sydney time. And I like to do this because it helps to break up the process into more manageable chunks. So we know that the flight time is going to take 14 hours and 20 minutes. So adding 20 minutes onto our 11:40 a.m., we get to 12 p.m. Adding on another 14 hours to that, we get to 2 a.m. on Wednesday, the 7th. Now, so that's what time it would be in Sydney. Now what we're going to do is take the LA time that we're actually going to land at in LA. So this would be the time in Sydney that we land in LA. So now we can convert it to the LA time. Now we've been told that LA is 19 hours behind Sydney time. Taking off 19 hours from 2 a.m., we should end up at 7 a.m. back on Tuesday the 6th. So as our final answer, we're going to say on what day and at what time will Gordon arrive in Los Angeles? 7 a.m. Tuesday, 6th March. And that's our answer to part A. Part B goes on to say, Gordon travels east to Atlanta and goes to 2 nightclubs. The second nightclub is located 112 meters away on a straight line bearing of 120 degrees from the first nightclub. So here we've got a club, and then if this is north, 120 degrees this way is going to be somewhere like that. And then we've got a second nightclub down there, 112 meters away. Part I then says, what is the eastern distance of the second nightclub from the first nightclub? Round your answer correct to the nearest meter. So if we were to break this distance up into an eastern component and a southern component, we get a little right angle triangle like that. Now, of course, because this is 120 degrees, 90 degrees would be directly to the west, so we're left with an angle of 30 degrees in there. And because we're trying to find the eastern distance, our unknown is going to be this edge up here, or the adjacent side of the right angle triangle. So because we're looking at the adjacent side and the hypotenuse, we're going to be using cos. So cos theta is equal to adjacent over hypotenuse. Substituting our known values, we should get cos of 30 degrees is equal to x over 112. Rearranging this, or if you've got a calculator, going straight to solving for x, we can say that x is going to be equal to 112 times cos 30 degrees, which, when that's rounded to the nearest whole meter, should end up giving us 97 meters. So we're now 97 meters away. Awesome. Part II says, what is the southern distance between the 2 nightclubs? Round your answer to correct to the nearest meter. So this is a very similar process with one slight difference. So we're using the same triangle again, except this time we're going to be looking for this side, the opposite side. So we're using opposite and hypotenuse. means we're using sine theta equals opposite over hypotenuse. Substituting our known values, we should get sine of 30 degrees is equal to y over 112. Rearranging again for y, we get y equals 112 times sine 30 degrees, which when we plug that into a calculator and round to the nearest whole meter, we should get 56 meters. So that was part II. We're then given a little bit more information. We're told in the following questions, assume that the radius of the Earth is 6,400 kilometers. The line of latitude around the Earth at latitude 34 degrees north is shown in the diagram below. And I'll do a quick little sort of mock-up of the diagram so we can keep some sort of reference here. But if that's the equator, we've got a line of latitude up above it, which we've been told is 34 degrees north. Awesome. So, we're in part C. We're being told to show that the radius of the line of latitude around the Earth at 34 degrees north is 5,306 kilometers when rounded to the nearest kilometer. So this is a little tricky, but what we're going to look at here is that this radius that goes from the center of the Earth out to the equator, or the radius from the center of the Earth to anywhere on the external surface of the Earth, is going to be 6,400 meters, which means that this line that goes from the center of the Earth, or this radius up to the line at 34 degrees north, is also going to be 6,400 kilometers long. And we want to find this radius. So what we've got is a little backwards Z. Of course, if you were finding it on the other side, it would look like a normal Z, but we've got a backwards sort of Z shape here, which I'll kind of mock up, because it'll be a little easier to understand what's going on here. So we've got something like this happening, where we've got the radius of the Earth and our new radius that we're trying to find. So we're trying to find this value up here of R. Now, there are a couple of clues that can help us figure this out. First of all, we know that this radius down here is 6,400 kilometers, which means that the line that goes from the center of the Earth up to this line of latitude is also 6,400 kilometers, because it's going from the center of the Earth out to its extremities, so it's going to have the same length. We also know that because of this 34 degrees north idea, this angle in here is going to be 34 degrees. So this one in here is 34 degrees. Which means since these two lines, radii are parallel, they're both also going to be 34 degrees. So what we've got now is this little triangle, which you may or may not be able to see so far, but I'll draw it a little bit more explicitly. So we've got a triangle that we can use to solve for this value R. So what you might notice is that we've got a hypotenuse and we're trying to find the adjacent side, which means, of course, we'll be using cos adjacent over hypotenuse. Once again, solving for our known values, substituting our known values, we should get cos 34 degrees is equal to R over 6,400. Should be equal to 6,400 times cos of 34 degrees, which if you plug that into your calculator, should give you an answer of 5,306 kilometers if you round to the nearest whole kilometer. So this process here is essentially the show that component of this question. So moving through that. The last question, or the last part of this question, part D, says what is the shortest curved distance between Los Angeles, which has a location of 34 degrees north, 118 degrees west, and Atlanta at 34 degrees north, 84 degrees west. Round your answer to the nearest kilometer. What you may notice about these two locations is that they're both on the line of latitude 34 degrees north. So there might be, for example, here and here. So this curved distance that we're looking for between them is going to not occur on a great circle, but it is going to be a curved distance, an arc length. So our formula for an arc is the one that you guys probably have in your book, is pi r theta over 180. So now it's our job to look at this and say, well, the radius at 34 degrees north isn't going to be 6,400 because we're not moving along a great circle, we're moving around a small circle. So the new radius that we should be looking at is this one that we've just proven before, the 5,306 kilometers. Theta, the angle between the two of them, is just going to be the difference in their location east and west of one another. So we'll take that 118 degrees from Los Angeles and subtract the 84 degrees west that occurs at Atlanta. Now, I've subtracted here because we are looking at 118 degrees west and 84 degrees west. If this was 118 degrees west and 84 degrees east, then this would then the question would change drastically. So we've got to be aware of like finding the shortest curved distance between those 2 points and how we do that. So if our answer ends up being over 180 degrees, we should find the 360 minus that in order to find the distance. I'm not going to go too far into explaining that because it's going to get confusing without a drawn diagram, but if you guys have questions about that, please leave them in the comments section below. Calculating the 118 take 84 degrees should leave us with 34 degrees. And now we've got the two unknown variables that we need in order to answer this question. So this arc is going to be equal to pi times 5,306 times 34 all over 180, which when you plug that into a calculator and round it to the nearest whole kilometer, we should get 3,149 kilometers, our final answer. If you guys have any questions about any of these questions, please leave them in the comments below. Otherwise, I'll see you in the next video.